Agora sim, tá bom. Boa tarde, pessoal. Bom, próxima apresentação aqui dos nossos parceiros da AWS vai falar de Machine Learning aí aplicado para e-commerce. E um aviso, a palestra é em inglês, tá? Tem tradução simultânea, se vocês quiserem, tem os fones aqui do lado. E o canal, só para lembrar, o canal que a gente estiver usando tradução simultânea em português aqui, o canal desse palco é o 5, tá bom? Com isso, obrigado, gente.
Hi everyone, welcome. I'm going to stand here so it's closer to everyone. My name is Kritika Ganesamurthy. I am the global technical lead for retail partners in AWS. So what I do in my role is I work with partners like VTEX, like IBM, like SAP, like Stripe to help them build solutions on AWS. I also help them with technical strategy and also go to market. I've been in AWS for about close to 4 years, but prior to that, I do come from retail. So I've got over 15 years of experience in retail, primarily in digital commerce, point of sale, data and analytics. So today what we're going to see is, I know machine learning it was sort of the buzzword 3 or 4 years ago because it was very new. Everybody was like, what is machine learning? What can I do? So today what we're going to talk about is what is machine learning in retail? And I'm going to focus a little bit on fashion specifically, digital commerce and fashion, because there's just a lot of new cool things coming out in the fashion side of things in machine learning. So let's get started. And I don't have to tell you about how much machine learning is growing. In the last 4 years or so, this is an IDC prediction that they think in 2024, the spending is going to go up to 110 billion. That's about 2 years from now. And we've seen that as being in AWS, talking to customers, we see machine learning being added in every aspect of retail. So when you think about retail, there is something called order to cash, which is how do I manufacture a product? How do I design a product? How do I manufacture it? How do I take it to a store or e-commerce? How do I sell it? And then how do I do returns and post-purchase, right? Retailers, when you think about machine learning, it was all about data platforms. But now retailers are thinking about adding machine learning in all aspects of retail. Supply chain transformation, what happened 2 years ago with all COVID pandemic? So when you look at a problem like forecasting, it usually is done once a year, maybe once in 6 months. But in pandemic, what happened is grocery retailers were forecasting every single week because nobody knew what was going to happen tomorrow. So in those cases, machine learning was very valuable because machine learning could look at patterns outside of their company to determine what those quantities and inventory needs to be. So machine learning is all over in all aspects of retail. A lot of things are being automated. So I wanted to start off with this, right? Because AI and ML is used interchangeably. People sometimes say AI when it is actually machine learning. And it's just used so interchangeably. So I wanted to just talk about what the terminologies mean. So when you look at artificial intelligence, anything that mimics a human action, you call that as AI. Something like Tesla, like driving a car, right? The car drives by itself. Yeah, it's a human who typically drives a car, but when you add artificial intelligence, you're making the car do things for you. But what is machine learning? Machine learning is more about making the machines predict, using statistical models or deep learning models to actually predict things for you, like forecasting. Forecasting is a classic machine learning problem because you're giving the computer the algorithms, a lot of transaction data, a lot of product data, a lot of weather information, external factors, and asking the machine to predict what it is. So those are classified as machine learning problems. Then you have deep learning. So deep learning is this multi-layer neural networks, just like our brain, right? You have so many information you're processing to come up with a decision. So deep learning models are precisely doing that. If you look at problems, like AI problems, a lot of AI is done using deep learning models. Again, I'm going to bring Tesla as an example. If you look at how the car works, there is a very nice YouTube video. If you're all car enthusiasts, I suggest you just go to YouTube and look up Tesla AI Day, where they talk about this deep learning models and how different, because they have to predict, you're riding on a road, you have to predict the traffic signs, you have to predict who's coming, you have to predict navigation. So there's multiple deep learning models running together to come up with the outcome. So yeah, so these are some terminologies I thought would be interesting to show you. Okay, so what do we do in Amazon specific to machine learning? As you know, Amazon spans across digital and also physical stores. On the digital side of things, again, from a shipping perspective, we ship almost 4,000 products per minute from Amazon.com. So that's the amount of products that is being sold on Amazon on a daily basis. We also do a lot of packaging. And our fulfillment center is completely automized. We have robotic automation everywhere. When you think about where robotic lies, when a seller, if I'm a seller on Amazon and I'm sending inventory to Amazon, there is a robot which decides, a robotic process and algorithms which decides which fulfillment center my inventory will need to be sent to. It also decides which shelf in a fulfillment center that particular object needs to go. And when a customer places an order, there are robots going around the entire fulfillment center, picking up the orders, bringing it over to pickers, and then they package and ship. So the entire process is automated. It has robotics, machine learning, and AI all built in. And the other thing, of course, we all know about Alexa, voice commerce. Again, a ton of machine learning models and AI built into Alexa, because Alexa understands, it needs to understand your intent of your question, right? So if you say, hey, I want to go running, Alexa will need to understand why are you working out? Do you need to know the temperature? Do you need to set a timer? Do you need to turn the tracking event on? So it needs to understand the intent of why you're asking a question, which is a very complicated problem in machine learning to solve. It's not that, because human mind, we all know how confused we are, right? So a machine to understand what you're asking is a complicated problem. That's why the NLP, natural language processing, is an extremely difficult problem in machine learning to solve for, because nobody can understand what each of us think. I want to talk about physical stores and what Amazon does. So in the last 5 years or so, Amazon has changed how you shop in a physical store. So we've taken out lines, we've taken out checkout. So the way Amazon Go, what it does is you walk into a store, there are cameras all over the roof. It identifies who you are, in a sense, because you have an Amazon app, you scan the app, you walk in, it has cameras all around, it tracks where you go, it tracks what items you pick, and once you're done, you just walk out. You don't have to go to a checkout line. So it's called Amazon Go, and we have it in multiple Amazon stores. We are also selling this technology to customers. If customers want to implement, we can help them. The second one, the other one right there, it's the Dash. You all have shopping carts. We actually have computer vision and machine learning built into this. So it can actually, as you take a product from a shelf, you can add it to the cart. It'll automatically calculate your totals. And once you're done, you can just walk out taking your bags off. And the last one, so this is a very cool technology. It's called Amazon One. It's used for identification and payment. So basically, we all have biometric. We all know like biometric, like fingerprints, your eye. So what Amazon has done is it looks at your palm. So everyone's palm, underneath your palm, your veins, the structure of your veins are very different. So Amazon is using that as a biometric technology to identify who you are, and that's the Amazon One technology. So if the next time, it's in the US, some Whole Foods stores and Amazon Go stores. So all I have to do is I have to register with Amazon. When I walk into a store, I scan my palm. It opens the gate, lets me in. It can track what I do, and I can just walk out. Because my card is associated with Amazon, it just charges automatically. I think this will be a very cool technology in airports. We don't have to go take a mask, scan a card. If you can just scan your biometric and just go and check in, I think it'll be very cool. So I think that's another latest technology we have in Amazon, where we're incorporating machine learning and everything else. So these are some retail use cases. We've been helping customers solve. Again, as I said, it's across the board of retail. not just in one area, which is digital commerce or supply chain. It's across, as you can see. It spans from like dynamic pricing or pricing optimization, all across like brand loyalty, customer retention. So it's across the wide portfolio. So, okay, so we know everybody wants to do machine learning, but what is stopping retailers from doing so? Again, the common problem we see is we don't have enough, like everybody has data, but we don't know what to do with the data. So there's always a struggle of, okay, my data is everywhere. I know you've all heard about this millions of times being repeated, but the wonder of this is it still keeps happening. We still keep getting asked by customers, hey, we have data silos, we don't know what to do. So that's why I think it's important to talk about this because, again, there are problems that still exist when it comes to what we want to do with data. And the way we talk to customers about achieving this maturity is we call a crawl, walk, run. It's like a baby, right? When they start crawling first, then they walk, then you learn to run. Very similar in business. When you want to solve a problem, take it slow. Do small experiments, see if it works, then keep moving on, right? And to reach the actual maturity of where you want to go. So when you look at what that model looks in analytics, so if you look at what you want to do is, you need to understand what problem you have now, which is what this box is. You know, what is my problem? Why did it happen? Those are some fundamental, basic questions you need to be able to answer with your data set. Because that's a foundation. Once you answer that, then you can get into predictive. Predictive is, okay, what's next? What will happen next? Is that customer who shopped with me yesterday going to come back to my site to buy that stuff? Can I predict that behavior, right? That's your next step in analytic maturity. Once you do all that, then you understand, okay, if I know that John Doe or Kritika is going to come back, what should I do to her? How do I make her experience better? Which is what the prescriptive is. Okay, what exactly is she going to be coming back for? And can I make her buy that particular product? The cognitive is, what does Kritika like that I just don't know, and how can I have her buy? I can give you a very good example of a grocery store in US. It's called Kroger. It's like Walmart. And what Kroger does is they send you coupons. So they send you 10 coupons. 5 coupons are for what you actually bought. Like, you know, if you buy a can of beans, you buy milk, they'll send you 5 coupons on the exact products that you bought, giving you some discount. Then the next 3 items will be something very close to that. You know, basically it might be a different brand of what you are already buying to open your eyes into other things that exist. The last 2 coupons will always be something very different that you didn't think about. That's the cognitive AI. So they're applying the cognitive AI to show me not only what I need now, but what I might need in the future that I didn't think about. So their entire coupon, the 10 coupons, is a play of all of this. It's like, okay, what does she need today when she grows? Yeah, she needs milk. She's going to buy milk. I'm going to give her a discount so she can go buy the milk. Then can I introduce her to another brand? That'll be another 3 coupons. And something else will be, hey, I didn't know Kroger sells, for instance, matchboxes. So there'll be a coupon for something like that, knowing my behavior. And so, yeah, and then again, data strategy, data silos we just talked about. The way we think about in AWS is bring all your data, bring it to a data lake. Once you get it there, you can do n number of things with it. You can do machine learning, you can just do operative analytics, just some of the very basics. So I wanted to talk to you about a machine learning stack within AWS. I know it has so many technologies. The fundamental idea in AWS is we want to democratize machine learning. What that means is any company with any capability, either you have expert ML people who can write the core algorithms, or you just don't have any machine learning expertise, we have you covered. I think that is the essence of the slide. So the bottom layer is for expert machine learning. Think about companies like Tesla, who's trying to build a car, who's trying to build machine learning. They operate at this level, right? So they have machine learning frameworks and infrastructure, companies like them. Snapchat is an example where they use ML frameworks at this level to predict how to create customer experiences, how to create the snap filters, like what should the next filter be? So they use a lot of this in this particular layer. So they build, their scientists and data scientists, they actually use machine learning frameworks like TensorFlow, Python, PyTorch, and MXNet to build those models. The second layer is more for people who do not want to own the machine learning pipeline. When I say pipeline, what that means is, let's say you have 10 engineers working together. They have to figure out how to create a Jupyter. Jupyter Notebook is sort of an IDE where you actually write code, like Python or whatever programming language you have to write the machine learning models. So this second level is for people who still want to write code. They still want to write something in Python, but they don't want to maintain the DevOps pipeline. Like, okay, if I have 10 people working, I need to scale. Then once I create the model, I need to deploy the model, which means I have to spin up compute instances. So if you're a company who does not want to do that, then you operate at this level. And if you are a company who are very new to machine learning, you have no idea how to create algorithms, but you want to do something, you start using some of our AI services. When you come to retail, we have like personalization, which is recommendation. You know, we all like recommendation. You go to Netflix, you see something, and there's immediately something else that pops up. YouTube, Amazon. So all of these recommendations are powered by machine learning. So we have services like personalized, like forecast for your forecasting that you can deploy without writing the machine learning model code. For retail, other applications are recognition. So Amazon recognition is, you know, you give Amazon recognition an object. Let's say you give me my picture. Amazon recognition will tell you, hey, what is my gender, male or female? It'll also tell you what ethnicity I am. Maybe it will tell you I'm an Asian. It'll tell you what my age group is. Then it could also tell me what clothes I'm wearing. So it can automatically do things like that, so you don't have to write anything. Just some stats on using Amazon SageMaker and why it's easier for companies who wants to use machine learning to do so. And again, I talked about Amazon Personalized. So these are all like purpose-built retail-specific services. Amazon Personalized and Forecast are coming directly, and Fraud Detect from Amazon.com. So 10 years ago, so in interesting stats is in 1999, Amazon wrote a paper for items-to-item similarity. What that means is, if I click a shirt, a blouse, a black blouse, there are chances I might like similar type of black blouses. So till today, I think Amazon is the only company who's got that algorithm right. There's nobody still able to beat the algorithm of Amazon, what Amazon has. We've taken all those algorithms and made it into a service which is called Personalized. Likewise in Forecast, Amazon has Prime Day, like your shopping, your holiday. We actually predict what the demand would be for a particular product, and we tell the sellers, hey, by the way, seller A, you're going to expect 100 products of your product, so please make sure you have it. So we run forecasting models for our third-party sellers, so they can actually go and make sure they have the right product. So we use the algorithms, deep learning algorithms, and we take those algorithms and give it off to customers, whoever wants to use, same Amazon algorithms. So I wanted to specifically talk about AI, ML, and fashion. Like, what are you in digital side? The first trend that we see, The first trend that we see is the fashion trends. I don't know if you're all aware, but there are a lot of companies in the US. They will go to Instagram, they will go to Facebook, they will go to Pinterest, they will analyze what the fashion trends are. They will tell you that, hey, by the way, this particular season, gray boots are very popular because that's what everybody is wearing. So the way they do that is, they take this image, they run something called multimodal classification model. That is, they apply deep learning methods to extract features from a particular image and then identify trends. This is a very popular thing that is going on in the US, where a lot of companies are trying to use machine learning to identify what the trends are so they can give it to the marketing team and say, hey, by the way, I think boots, pointed heel boots are very popular, high ankle boots, knee-high boots are popular, so go promote that. The second trend we see is more accurate assortments, basically assortment planning. How do you know that this particular store needs to have this particular products in this many quantities? So that's another trend that we see going on. The other trend is the visual search. this is another popular trend wherein a customer, let's say there is a bag, you take a picture of the bag, you see a very nice bag somewhere, and you are like, oh, I want that similar, I don't know what brand that is. You're able to take a picture of that, search on a website, and it'll actually pull you products similar to what that is. So it's instead of typing something, you're using pictures to actually do search. So this is another popular, very popular trend in the US. Amazon has a lot of features enabled on .com where you can actually do something similar. The next one is product discovery. I'm going to talk about it a little bit more the next slide because that's another trend that we're seeing. And then in the visual, we do recommendations as well, like not just knowing what products, but again, incorporating recommendation into that. This is something called generative AI. I don't know if you've all heard of this. So it uses something called GANs. It's called Generative Adversarial Networks. It is called adversarial because what it does is, I don't know if you've heard of deep fakes. It's a problem in internet now where people are able to fake images, voice, and everything else. I know that there's ethical issues to that, but in terms of retail, what you can do is you can apply GAN, which is Generative Adversarial Network, to create products that are similar to how it looks for you. For instance, the 3D imaging. So you might have a 2D, so let's say this is a controller. It's a 2D object. I don't know I can take a picture of behind, but if I want to see how it looks all over, I need a 3D model of this. And the way you do a 3D modeling is, you take 2D pictures of this particular image, you take multiple pictures, and you let the machine determine what the sides of it are. It puts together a 3D model for you. And the way they do it is, they have like two sort of networks. One is a generative network and another discriminator network. The generative network creates all these multiple images of this particular thing. The discriminator basic's job is to see the new images that you create, how close is it to the actual image, right? So they pit against each other. So that's the GAN model. 3D is another very popular. You hear about metaverse, you hear about NFTs. I just listened to a podcast from Mark Zuckerberg last week where he's talking about this metaverse and how we're all going to be living in this 3D reality very soon, how we're going to be working in 3D. A lot of companies like Nike, they've created metaverse experiences, which is you get into a game and the entire game has Nike products all over. So there's a shoe, there's apparel, there's experiences. You go in, you can put together a Nike shoe, you can create avatars with Nike sweaters, a Nike hat, a Nike shoe. You can actually walk around in the metaverse. So there are a lot of retail companies trying to create 3D images and then using that in a metaverse to create those visual experiences. So I think in the next few years, this thing is going to take off. So the product discovery, I just wanted to emphasize again, because this is another trend in e-commerce we see. If you're in retail, you know what merchandising is, right? Like we have merchandisers taking a particular apparel and saying, yeah, this is black, it's short, it has 3/4 of length, this is a type, it's a silk. Instead, what they're doing is they're letting machines give an image, and the machines will extract attributes. The machines will say this is a black color, this is a short sleeve. So that way you don't have to put humans into creating what these different attributes are. So this is another popular trend. I want to talk about a case study. Tapestry, it's a very famous brand in the US. I'm not sure if you know. They own Coach. Coach, I know all of us know what Coach is. They also own Kate Spade and Stuart Weitzman, so that's another brand. So Tapestry runs on AWS. They run a lot of machine learning on AWS around different aspects. So I'm going to talk about a few things in terms of fashion, what they do. They presented us in reInvent. So what they do is, let's say you have a handbag. I talked about extracting attributes from products in terms of color and length. What Tapestry is doing is they're creating numbers out of it. So this blouse, because it's black, it might have a number 5 or something. So they start creating numbers for different attributes. And what they do with that is, once they create these numbers, they feed multiple images into this machine learning model, and that model will spit out numbers. When it does, it looks like that. It looks like that. So what happens is their merchandisers are able to look at this graph to identify, because like fashion, you have so many SKUs. It's seasonal, right? It's a seasonal industry. You have a lot of things that change from fall to winter to spring and summer. And you don't know, and Tapestry has been around for like 4 decades. You don't know if you've got to create a similar product, right? So what they do is, they make sure they send it into this machine learning model, they generate all these attributes, then if I'm having a new design of a handbag, that model will tell me, hey, by the way, this particular handbag that you're just designing was actually sold in fall 2015. Do you still want to do that, right? Because as a human, you may not remember all the products that you had, but a machine can. So that is how they're actually taking all of these data and extracting attribute information to help them actually decide new product design. Also, they're actually trying to do forecasting with it. Also like a forecasting model, like how can I plan for the right assortment in the store, all depending on those. There are different ways to do different things. This is just one example of how Tapestry is changing attributes into number, like mathematical representation, to do that. So yeah, so I think, so I just wanted to give you a list of customers who use machine learning today on Amazon, like across AWS, across like the 3 verticals that you saw. And and then in terms of like what you can do, there are multiple programs, there's like training, there's concepts, there's POC. There's a lot of GitHub repos. You can actually go Google. There's a lot of GitHub repos on models that you can actually start using to solve some of your problems. And of course, we have this entire AI ML stack. Yeah, that's all I had. Any questions? I know that was pretty fast, but I just wanted to make sure we cover all the important things. Any questions?
Tá ligado aqui? Se vocês quiserem perguntar em português, a gente traduz aqui, tá? Se alguém tiver alguma pergunta, quiser perguntar em português ou em inglês, tanto faz. Alguém quer fazer alguma pergunta? I think you explained it too well.
I don't know.
Right?
But thank you so much for listening. And yeah, have a rest. Enjoy the rest of the show. Thank you.